Hi everyone, welcome back to math. So today we're going to learn about chapter 4.4 on fractional exponents and radicals. So now our exponents are going to be fractions. So first you need to get familiar with using your calculator and how to calculate fractional exponents. So I did post a video that's on the classroom going over it on an iPhone calculator. If not, just give it a try, watch that video, try to relate it to your own calculator. It should be quite simple. The whole idea is to put the base in and then hit to the power of button and put brackets around 1 divided by 2 in this case. Okay, so give it a try and see if you can get these answers. So 9 to the power of a half, 25 to the power of a half. Okay, so start off there, watch that video. Ask me questions, send me a picture of your calculator if you need some help. So you need to think and see what you can relate and recognize is how do the numbers in the denominator, so denominator is the bottom number in the fraction, so how do the numbers in the denominator position relate to radicals? So radicals are our square roots, our cube root, our fourth root. All right, so try to think about it, and I'm going to tell you here in a second, but try to think yourself. So what do you think this number could become in a radical? Okay. So powers with fractional exponents where the numerator is 1. So that's a fraction of like a half, a third, a fourth, a fifth, a sixth, a seventh, right? So 1 over 7, 1 over 8. So when n is a natural number, so see that's talking about the denominator. N is the denominator. It's a natural number, so 1 to infinity. And x is a rational number. So we know about rational numbers. We did that on our first day. So our x is our base. Right? So what happens is when it moves into a radical, the n, the denominator, becomes the index. So I know a lot of people have been having some issues with the index and getting confused of why there's a little number beside the square root. That's your index, and that tells you what you're doing to the number inside, right? So usually it's a 2, a 3, a 4. So if this was a 2, it would be a square root of x. If this was a 3, if this was x to the power of 1 over 3, it would be the cubed root of x. Okay, so look down here. The square root of any number is equal to the number to the exponent of a half, or the cubed root of any number is the number to the exponent of a third. So let's look at that in some of these examples. So if we have 23 to the power of 1/3, so our numerator is 1 and our denominator is 3. So 3 becomes our index. So we put the root symbol with the 3, and our base is the big number down here. So we put 27 inside the root symbol, and then just strictly calculate that. So all you have to do is the cube root of 27 in your calculator and you will get 3. So let's look at b. So it's okay if it's a decimal. That's still a rational number, right? Because it terminates, it ends. So 0.49 to the power of a half. The 2 becomes our index. When it's a square, we don't often have to write the 2, but you can. So it's the square root of 0.49, and that equals 0.7. So rational numbers can be negative too, right? So we just put that in our calculator. So the 3 becomes our index. So a cube root of negative 64. So you're going to get negative 4. And then, it can still be a fraction, right? We've seen that rational numbers can be fractions. So the easiest way to do that is just we have a denominator of 2, so that's our index. So we're going to square root the top and the bottom. Square root the numerator and the denominator. The square root of 4 is 2, and the square root of 9 is 3. Okay? So now how about powers with fractional exponents that are not like 1 over 3? How about if it's like 2 over 3, where the numerator is a number other than 1? Okay, so when a and b are natural numbers, so 1 to whatever, and b is not 1, and x is a rational number. So we know rational numbers. So let's look here. So x to the power of a over b, so a fractional exponent. The a, we know what b becomes, right? Because that's what we just did in the last slide. B becomes our index, right? Our number in the root symbol. But a, it becomes the power on the base. So it would be x to the power of a. So it's also the same as putting brackets around the root, okay? So that's another way to do it. So b becomes our index and a becomes our power on the base, the power on the x. Okay, so the exponent's numerator is the power on the x, and exponent's denominator is the index of the radical on the base. So that tells you what root to take. So let's look at a few of these. But we also need to remember that a fraction can be written as a terminating or repeating decimal, right? So therefore, we can interpret powers with decimal exponents as a fractional exponent. So if you have a power that is a decimal, change that to a fraction. It will make it a lot easier. So if we have 0.4, we know that that's to the 10th, so that's 4 over 10, and then reduce, always reduce, so 2 over 5. So if we have 50 to the power of 0.5, we change the 0.5 to 2 over 5, right? Because this is going to make us have the fifth root of 50 squared, right? How about over here? We have this to the hundreds, so you put 125 over 100, reduce 5 over 4. So if it's 16 to the power of 1.25, it now becomes 16 to the power of 5 over 4. Okay, so improper fractions are okay. Okay, so remember that when you get a decimal exponent, change it to a fraction. So now we need to write these powers as radicals. So let's look at A. So we have negative 42 to the power of 1 over 5. So this should be quite simple. This is just what we did on the other side. The 1 is what our power becomes of the base, and 5 is our index, right? So always start with the denominator. The 5 goes in front of the root symbol, and then it would have a 1 right here, right? Negative 41 to the power of 1. Oh, let's look at B. This is a good one. So what you need to know is you can write these in two different ways. Okay, so that's what I've explained here. So 28 to the power of 3 over 2. Look at the denominator. Our denominator is 2. So the 2 is our index. So we don't have to write a 2 for a square root, right? But our 3 becomes our power of the entire root. So it's the square root of 28 to the power of 3, or you can put the 3 right next to the 28. Doesn't matter to me, okay? So, here's a decimal. So we need to change 1.5 into a fraction. So that's to a 10th, so 15 over 10 equals 3 over 2. So 4.8 to the power of 3 over 2. So our denominator is 2, so we're going to have an index of 2, so a square root of 4.8, all to the power of 3, our numerator. Okay, so square root of 4.8 to the power of 3. Okay, how about this one? We have exponent of 0.25, so that's going to become 25 over 100, right, because that's to the hundredths. So that equals a quarter, so 3 over 4 to the power of 1 over 4. So we're going to take the denominator, right? Take the 4 and put it as our index. So now we're taking the fourth root of 3 and the fourth root of 4. Okay? So now let's just go backwards, okay? So if we have the square root of 41, what is our index? There's no number here. So if there's no little number, it means it's a 2. And is that the numerator or the denominator in a fractional exponent? It's the denominator, right? And it's not to the power of anything, so we know the numerator has to be 1. So we put the same radicand, we put the same base, so 41 to the power of 1/2. Or we have B. So we have the cubed root of 63. So our index is our denominator of the fractional exponent. So we're going to have a third, so 63, and then we have no power, or no power of the base. So it's going to be 1. So it's going to be 63 to the power of 1/3. Okay, so this one has a power of 5, right? So what are we doing here? We're doing the square root of 3 over 10. So our index is 2, so that's going to be our denominator, and the whole term is to the power of 5. Now that's our numerator of the fraction. So we write 3 over 10 to the power of 5 over 2. Okay, how about this one? We have the cubed root of 5 over 13 squared. So our index, look at your index first, that's the denominator, the bottom of the fraction. So it's going to be 3, and then the power in the root is 2. So that's our numerator. So 5 over 13 to the power of 2 over 3. Now, I cut off our work today, so it's just going to be writing the radicals. Okay, you're not going to have to evaluate, that'll be tomorrow. So all you're doing is practicing writing the radicals or practicing writing the fractional exponents. So give these a try on page 227. If you have any questions, let me know, email me, come join the Google Meet, and we'll try to solve those questions, okay? Have a good day.